All right, great. Thanks for having me. So yeah, what I'm gonna talk about today is just what the current progress is in our development roadmap, and also what opportunities and next steps we see with ROS2 in general, and what we hope we can realize in the soon future. Um, Looking at MoveIt's evolution, there are some steps where you see major breaks, and especially the last break in 2019 was when MoveIt was released as a full major version. So that's the point where we at PickNik tried to consolidate the MoveIt project into something that you can actually also use for production, or for something that you can be sure works and is not only a tool for research and development. With MoveIt 2, we have the great opportunity to continue that goal, or to continue aiming for that goal, and deploy more methods of quality, and also try to really provide that level of safety and quality that ROS2 offers, and also to make a step forward, just breaking more from the legacy code, and to just really push forward to making more features available in MoveIt 2 that were not available in the past. Looking at the tool set that MoveIt provides, you could say that MoveIt is pretty much an aggregation framework for all of the different parts that you want to use in a robot system. So you can do motion planning, manipulation, IK controlling, 3D perception, collision checking, and all of that parts are extendable. So you can plug and play all of that things, just because MoveIt is designed so that you can replace plugins or nodes that communicate with messages, and that allows you to really prototype a complex robot system really fast. The problem was that often companies and also research groups used MoveIt for prototyping, but didn't really turn out using it in production as much because of the limitations that were just they're given in the system. And we hope that we can eliminate that with ROS2. Also here, a little overview about all the different parts that MoveIt provides. Most of it provided using plugins. For instance, the planners are all run using plugins, IKs run using plugins. And the interfaces are designed using message types. And that is a really good starting point for allowing to use the same structure in ROS2 and still providing the real-time safety and quality that ROS2 offers for production code. So question, why ROS2 versus ROS1? We have real-time capabilities. It's designed for production, but we have the same support for research and development. And it provides multi-platform support, Linux, Windows, and macOS. Of course, there are a lot of other points why we would move to ROS2, but currently these are really the biggest driving factors why we do that. Here is the current development roadmap of MoveIt 2. Don't worry, I won't go through all the bullet points here. So currently we're still working on Milestone 1, which is the straight port to ROS2, which means refactoring all the message types, refactoring the message interfaces, action services, logging, node handling, launch system, all of the basics that you need for running MoveIt. So this already requires, of course, branching of the old MoveIt repo, but we still try to aim for feature parity. So we are still syncing with MoveIt 1, and in the end, we want to have a full release that allows really migrating from MoveIt 1 to MoveIt 2 and don't miss anything. So it should be really an easy migration, and you shouldn't really notice that you're using a completely different infrastructure. So we want to make it really, really easy to move to ROS2. Milestone 2 is real-time support, which means that we want to use ROS2's real-time safety features for enabling better support for closed-loop control, reactive adaptive planning using hybrid planners, and also real-time control using a better integration with ROS control. The bullet point at the bottom, you see integrate pulse industrial motion. This is also a part which also is already being done for MoveIt 1, so it doesn't really belong into this roadmap in particular anymore. But with MoveIt, with Milestone 3, fully leverage ROS2, this milestone really focuses on refactoring the MoveIt code base to better match how a system in ROS2 should be designed. That is structuring the MoveIt code base so that we communicate, for instance, with component nodes instead of direct APIs. Managing the life cycle of the MoveIt nodes in that case. So maybe allowing to dynamically starting and stopping planning scenes, parts of robots, making maybe even the robot model dynamic, exchanging of grippers. So all of that plays into this step as well. At the bottom, you see future milestones, determinism, improved interfaces, state machines, machine learning. These are more like a wish list at this point. So I won't talk a lot about these right now. So for the current state, status update, currently we are in the last phase of milestone 1. So the straight migration is about 85.5% done package-wise. So 53 of 62 total targets are ported. We can already do all of the things that you could do with MoveIt Run currently, just using the MoveIt CPP interface. So there's a demo that shows you how to use MoveIt CPP for running a full plan execution pipeline. So you can launch OwnPL, for instance, name a target, run a motion plan request, and collision checking works, IK works. So all of that is there. So what is still missing is support for the move group and move group interface way of running MoveIt. But this will be done in the next weeks. This is currently work in progress. Then there is a real sum of code project going on. Adam Pettinger is mentored by us to port JogArm to MoveIt 2, which is also not an unimportant part, because lately we have put a lot of effort into refactoring JogArm and making it a lot better. And I think it will play a major role in the next milestones, also on probably for closed loop control features. But this is still under discussion, so I'm just it's just a little sneak preview. Preparing Foxy 2.1 beta release for July 2020. Yeah, we are working on it right now. By July, we want to release Foxy support. So, and from then we will support Eloquent and Foxy at the same time. And also good news, milestones 1 to 3 are supported by ROS-I. Check out the link to see what it actually means, and what we're currently working on, and check it for updates as well. Also, we have great contributors from Intel and OSRF who really put a lot of effort into creating PRs, party packages, and reviewing. Now, after this update, I want to give a little insight about MoveIt 2 with real-time support, and what that actually means, and how we want to redesign MoveIt in order to use that features. So real-time safety is actually really required for robust online robot manipulations. So that means complex interactions with the environment that require some kind of dynamic reactions maybe based on forces, based on vision input, based on reacting planning scenes. This always requires recreating or recomputing the plan that we currently have, and that must always take place immediately. We can't afford to maybe have a little delay in reacting to a collision object, because otherwise we might crash it, of course. That means we have different use cases on where we want to apply real-time motion planning. And that is reactive closed-loop control. Also, the high rate of joint command streaming. That means the reactive closed-loop control is running real-time motion planning in order to eliminate delays when reacting to incoming sensor input. The high rate joint command streaming, this one applies real-time safety for communicating with the controllers. And then we want to have a really low latency chain from sensor to the control pipeline. And that not only plays a role for open loop control, closed loop control, but also for online planning. So we have like different use cases for that. So the overall Milestone real-time support that you saw above pretty much consists of 3 features that try to solve one goal or one problem. We want to achieve, or we want to provide an approach that allows the user to run robust and dynamic motions, but we don't really want to limit the user to a certain solution here. So we really focus on the framework at this point. But this framework should provide support for adaptive and reactive closed loop control. Also, feature 2 for dynamic trajectory execution using hybrid planning. And feature 3, zero memory copy integration with ROS controllers. So that already tells you a little story here, because the adaptive and reactive closed loop control is like the first step. The dynamic trajectory execution using hybrid planning is a step forward from there. And the zero memory copy integration with ROS controllers is a requirement that we need for the previous features. Looking into those features, reactive closed loop control is running really trivial, simple motion based on a dynamic goal or path constraints. Examples are, for instance, vision-based closed loop control, picking an object that is moving currently, maybe placed on a conveyor belt. You're taking your vision input, checking the object, and then moving the arm towards the object and grasping it. You can't do that offline, because you don't always know how it moves, of course. So you have to react to your vision input. Force-based, there's an example, pulling a lever. If you would only plan a trajectory for that, you wouldn't know if you might be able to run it with the current force, or if you might break the lever if you run it too hard, or something like that. So you need to have some kind of fine tuning here. Also tightening up a screw, maybe for a certain amount of force. That is also a use case. A positive approach that we also implemented in some of the other way already is using jog arm for computing the position controls based on some vision or some force input. So this is already a really simple pipeline that would probably be possible in MoveIt 1 already, but of course not providing the safety, the real-time safety. The biggest problem with closed loop control here is, of course, only works locally, gets stuck in local minima. For this problem, we directly go to feature 2, which is hybrid planning, to always include a global solution. Hybrid planning in itself is a really generic approach in solving 2 different problems at the same time, and using the problem solvers. The problems are solving, of course, a global and a local problem, and you combine both solutions to create an immediate current output. Here, example applications are human-robot collaboration, painting a wall. Here, for instance, you would plan a global trajectory for painting and using a local planner for for providing the pressure on the wall that is required for applying the paint. Filling a dishwasher, anything that is really complicated requires you some kind of a global trajectory, but still some kind of local reaction to the environment. Also balancing a tray while placing a table. Yeah, those are really, really tough problems that were not really possible with MoveIt 1 and offline planning. Here a little comparison between global and local planning. So global planning could be a sampling-based planner like OMPL, could be something like Traject or Strump that is optimizing the plan already. But usually it's a planner that really computes complex motions in that are collision-free in a complicated world. So it could move around collision objects. It's not getting stuck in local minimum. This is really important. And it can be slower than the local planner. It can be a lot slower even. The local planner should be something that can be iterated really, really fast in a high frequency. Simplest way is probably a Jacobian-based solver that just gives you a point for a target pose, or any other IK solver that allows optimization. Or for instance, force-based IK solver that just approximates poses for a local desired force target. So all of that is possible and can be computed in a really simple way, so that this can be run deterministic and fast in a high frequency. But it might not be able to check for collisions that much. It really depends on how it's set up. That means we want to provide an interface for allowing to use hybrid planning to solve reactive or adaptive motion planning problems. Adaptive being like, again, drawing on a chalkboard. You have a global planner that defines the motion, and the local planner follows the motion while controlling for a local or constraint or path constraint. Or you might be solving a reactive motion problem, which is the global planner has to iterate the plan again and again, so that it doesn't get stuck that it allows reacting to changes in the collision scene. So for instance, if you have a human-robot interaction scenario, the reactive motion would allow you to replan a trajectory if there's a collision object in the way. And then the local planner would simply follow the newly completed plan by the global planner. So there's still just one problem. ROS controller and node communication latency will probably still not allow that fast update rates that we need. So in order to allow running all of that in a safe way, we will implement zero memory copying with ROS2 controllers, and probably we also run composable nodes in MoveIt, which belong to Milestone 3 for fully leveraging ROS2. Here's a really simple example about how we are planning to implement that. So currently in MoveIt, we already have MoveIt CPP, which allows you to replace the previous way of implementing your application using MoveGroup just by directly running the core components of MoveIt. So we already eliminated one ROS layer in the setup, and pretty much simplified the way of or the pipeline of user input or application input and controls by one step. MoveIt CPP offers support for running multiple planning pipelines at the same way, at the same time. So this is already a requirement for running 2 planners at the same time, like in the global planner approach. Of course, we can also plug in JogArm here, or JogArm could act as a local planner as well, because JogArm is basically a Jacobian solver. So we really want to make this, extensible and should be easy to configure at the same time. The MoveIt2 architecture would then run those components as component nodes, so that you wouldn't really have to implement the you wouldn't really have to launch the different nodes separately and then use the ROS messaging infrastructure here, because you definitely have direct communication between those nodes, which eliminates delays between the different components. So you will have a direct feedback from MoveIt CPP and ROS2 control. And also, if you have a vision pipeline running somewhere, those should also be possible to apply as a component node, so you can eliminate any delays between those components. Here an example about just running 2 planners inside MoveIt CPP. On a side note, we are also working right now on using MoveIt CPP as a move group context in MoveIt 1. So further down the line, it might even be possible to use the same approach, local planner approach, using a move group capability, but this will probably take a bit more time to finish. That's pretty much an insight into real-time support. If you want to get involved, here's a list of really interesting topics that we are still discussing about and trying to find best practices for. So examples like basic launch configuration and node lifecycle management. This is still an issue because, as you probably know, MoveIt Setup Assistant is really not trivial to set up with generic robot setups in ROS1, and doing the same thing in ROS2 probably requires refactoring most of that structure. But at the same time, this really allows us to improve what the MoveIt setup could look like, and maybe even add support for generic robot models, exchanging tools like Jorge suggested, and a lot more. We're still looking into best practices for parameter declaration, lookup, and sharing. So our goal is to have, of course, like all parameters in MoveIt declare themselves, so that the nodes really complain if something is missing, and it should be really straightforward to know what is wrong in your parameter setup, because I feel like with MoveIt 1, it was always a pain that there are so many config files and so many different ways to configure your setup, so that it's really difficult to maintain at the same time. So we want to really simplify that. We're looking into ROS1 legacy support, either using bridges or also providing a really simple migration guide. We're working on branch repo syncs and release strategies. Dynamic robot model description, as I already said. Also, how we want to design the composable node architecture, how we want to redesign the interfaces. Do we want to provide direct interfaces to the different components, so that you could maybe run IK or planning scene individually without the rest, so that for any kinds of prototyping. Enhanced ROS2 control integration, also looking into how we could improve the way MoveIt and ROS2 interact. Native support for state machine integration, this is a future milestone, and also replacing the current pick and place pipeline capability with an MTC enabled version, which should allow also customization and probably a lot more capabilities that we could add that way. All right. Yeah, if you want to get involved, just check out the repo, ping me, add new features, do reviews, or yeah, we are looking for financial contributions via code sprints and grants as well. Documentation is always really helpful. And if you find any bugs, please, yeah, report or fix them. Upcoming events, November 17th, we have the MoveIt. Still not so sure if that will take place online or in place, but anyways, more information will be given on the MoveIt website. Thanks.
Thank you, Henning. Are there any questions for Henning on the status and work going on around MoveIt 2?
Yeah, this is Matt Hansen. Hi, Henning. This is super exciting work you guys have done, and yeah, especially on MoveIt 2. I'm really excited to see the progress you've made. I did have a couple questions. So according to your milestones slide, it looks like you said you're almost done with milestone 1. That's the July release. Is that right?
Yeah, I can go back to that roadmap if you want.
So
the roadmap includes the straight migration. So that is all packages are ported. Of course, full migration is done. Code base is cleaned up. That's the milestone. The release in July is the ROS-I release, which means that it will still be a beta release. We don't really expect that we will get to 100%. We try to, but probably it will still be a limited version where
okay, so it's not quite all of milestone 1 yet.
Yeah, so the ROS-I release is not really targeting milestone 1. So those run at the same time.
Okay.
And then we will continue syncing the versions, of course, and then with the next version, we will provide a full release, and then milestone 1 will be done.
Okay, and then that invites a couple other questions, sorry, I wanted to ask. So for the beta then, will there be some, demoable functionality at that point? Will there be, will you be able to run a demo using MoveIt 2 essentially at that point?
Yeah, so yeah, we will definitely iterate on the current demo that we already have using MoveIt CPP. So that is already there since the current release.
Oh, okay.
Okay. So yeah, you can already check that out and play around with it. So everything is in place. You can do basically everything that you could do with MoveIt 1 except for the perception pipeline or like using the MoveGroup interface. But MoveIt core is pretty much fully ported. I think Bullet is still missing, but except for that, MoveIt core is complete. And you have VRK solvers, you have planning scene monitor, you have planning pipelines, trajectory execution, it's all there. The only limiting factor right now is still better integration with ROS control. So currently our plugins are not really using the new ROS2 control actions yet. But you can use your own ROS control setup if you just just check out the demo. There's a little explanation in there.
Okay. And then for milestone 2 and 3, those are also supported by ROS-I, right? Do you have any expected timelines on that?
Yeah, that's a really interesting question because as maybe already indicated by how I described the real-time support, part of milestone 3 will probably be required for getting milestone 2 completely done. So that means we are right now looking into particular ways of adding real-time support for closed loop control. And at the same time, we are looking into leveraging the ROS2 component nodes. So we're pretty much working on milestone 2 and milestone 3 at the same time because we're factoring the MoveIt basics or the MoveIt architecture is probably required for completing real-time support. So my timeline would be that we will start with those after the beta release in July, because Milestone 1 will be completed by end of July, probably beginning of August. That's my estimate. And then we will directly go to real-time support and fully leverage ROS2.
Do you believe that those are, I mean, can you give me any kind of scale on those? Do you think that they're like 6 months more work or a year's more work, or I'm just trying to get an idea?
I think it's really hard to say, but I would say 6 months probably. I would estimate that Milestone 3 will be done before Milestone 2 is completed. So for Milestone 3, I would estimate 6 months. For Milestone 2, I would say with reactive closed loop control will be done first. Probably takes about maybe 3 months. And after that, the global and local planner, for that, it's really depending on if we find good and functional setups and combinations of planners that really work the way we intended to.
Okay, thank you very much.
All right. Henning, before we wrap up, there was a question on the chat from Omar. He said, about the milestone to divide the planner between global and local, it has been considered to join the concepts of ROS2 navigation, which divide in local, global, and recovery.
Sorry, can you repeat that?
Can you view the chat? It might be more efficient.
Yeah, somehow Zoom is a bit.
I can try reading it again.
Now. I'm not sure what's going on.
So you had a milestone about dividing planner between global and local. So I guess in navigation, they considered local, global, and recovery.
Yeah.
Have you considered that for MoveIt as well?
Yeah, so that's an interesting question. Well, as I see it, the recovery might be another planner setup in that way. So it would be part of your application. The recovery depends on what your failure case is. We don't really consider that yet because we rather see the planning problem itself as the core problem. But it's a really good question. So maybe we can sync up there. What I would expect is that we could also think about integrating parts of like the navigation capabilities there, or maybe standardize how the interface would look like. Currently, we're more looking at the architecture of how we want to provide the different nodes and components, and what we actually require for it to run. So I would estimate that it would probably be another layer on top of that. Yeah.
Thank you.